Okay, number 52 in section 4.3 requires you asks for the critical numbers, which is where the derivative equals 0 or is undefined, and then it asks you for the intervals where the function is increasing or decreasing, which is we'll look at the sign of the derivative on either side of its critical numbers, and then we have to determine whether the critical numbers are max and min, which we'll do by looking at using the first derivative test in our analysis of where the function is increasing and decreasing. So we'll begin by looking at y prime. This is a quotient rule. So you're going to do the derivative of the numerator, which is 1 over x, times the denominator, which is x, minus the derivative of the denominator, which is 1, times the numerator, which is ln x, all divided by the denominator squared. Simplifying here, you're going to have 1 minus ln x over x squared, and you want to set that equal to 0 and see where it does not exist. Now let's tackle where it does not exist first. This function y prime does not exist when x equals 0, but notice that x equals 0 is not even in the domain in the original function. Because you're dealing with the natural log, this function is only defined for x is greater than 0. So we don't have to worry about where the derivative does not exist because that's not a problem here. It's not going to happen. Right? So we only have to worry about when the numerator equals 0, because that will be the critical number of when the derivative equals 0. And so then this is just asking you for when does ln x equal 1, because we move the 1 over and divide by -1. The way you undo the natural log is to kind of raise, e it is my sort of fashion language there. And e to the ln x, remember those functions undo each other, so you're just going to get x. And then e to the 1 is just e. So e is your critical number. So now you're going to draw your number line. Now your number line has an open parenthesis at 0 because our function was only defined to 0, from 0 to infinity. And then we'll put e in, which is about 2.718. So now we need to test numbers between 0 and e, and then from e to infinity on our derivative on y prime. Okay, and so probably one of the best ways to do this is just to use your graphing calculator. So let me get my calculator to come up. I guess I thought it was up earlier, but so we'll come in here and we will change this to our y equals, and we'll put our derivative in here, which was 1 minus the ln of x divided by x squared. And we want to try numbers. We'll go to our table and we'll try numbers to the left and right of e. And obviously, if you put e in, you will get 0. Okay, so to the left of e would be a number like 2, and you get positive y values, and to the right of e would be a number like 3, where you get negative. So to the left of e we're positive, to the right of e we're negative. So for some reason my computer's acting up, I lost all of that. But on our derivative, we started at 0 and we got e, and we found that to the left of e we got positive y values in our derivative, and to the right of e we got negative y values. So that means that, I don't understand why this is doing, that means that our original function was positive and negative. And so that means our original function is increasing and then decreasing. So if you're increasing and decreasing, then you have a max at e. And to figure out what the max is, you plug it back into the original function. So y equals the ln of e over e. The ln of e is just 1 divided by e. So that's your y value of your max. So you have a max at e, comma, 1 over e. And the function is increasing from 0 to e, and then it's decreasing from e to infinity. Okay?